We are given that x1, x2, x3 and so on till xn are an arithmetical progression with a common difference of alpha, and therefore the kth term xk can be written as x1 plus k minus 1 times alpha, and the difference between any two consecutive terms, say xk plus 1 and xk, is equal to alpha. Next, consider the expression tan of xk minus tan of xk minus 1. The first term can be written as sine of xk divided by cos of xk, and the second term can be written as sine of xk minus 1 divided by cos of xk minus 1. Taking a common denominator, the numerator becomes sine of xk times cos of xk minus 1 minus cos of xk times sine of xk minus 1, and the denominator is cos of xk times cos of xk minus 1. The numerator simplifies to sine of xk minus xk minus 1, and the denominator remains as is. Now in the numerator xk minus 1 is alpha, and therefore this whole expression simplifies to sine alpha times sec of xk times sec of xk minus 1. Now in this equation we put k is equal to 2. So the left hand side is tan of x2 minus tan of x1 is equal to sine alpha times sec of x2 times sec of x1. Similarly, put k is equal to 3. We get tan of x3 minus tan of x2 is equal to sine of alpha times sec of x3 times sec of x2. Put k is equal to 4. We get tan of x4 minus tan of x3 is equal to sine alpha sec of x4 times sec of x3. And we keep doing this till k is equal to n, at which point the left hand side is tan of xn minus tan of xn minus 1. The right hand side is sine alpha times sec of xn times sec of xn minus 1. Now we add up all of these results. Tan x2 cancels with the tan x2 in the row below it. Similarly for tan x3 and so on. And on the left hand side we are left with tan of xn minus tan of x1 is equal to, on the right hand side, take sine alpha common and we're left with sec x2 sec x1 plus sec x3 sec x2 plus and so on. The last term is sec of xn times sec of xn minus 1. And therefore sine alpha times sec x1 sec x2 plus sec x2 sec x3 plus and so on sec of xn minus 1 times sec of xn is equal to tan xn minus tan x1, which can be rewritten as sine of xn divided by cos of xn minus sine of x1 divided by cos of x1. Taking a common denominator, we get sine of xn times cos x1 minus sine of x1 times cos of xn in the numerator, in the denominator cos of x1 times cos of xn. The numerator simplifies to sine of xn minus x1. The denominator remains as is. Now in the numerator, xn can be replaced with x1 plus n minus 1 times alpha, because it's the nth term of the AP, minus x1 in the numerator, and then divided by the same denominator. x1 cancels in the numerator and we are left with sine of n minus 1 times alpha in the numerator divided by cos of x1 times cos of xn, which is the desired result.